Okay, so today I'm going to be going over how to find the inverse of a 2 by 2 matrix. So when you're doing a lot of linear algebra, you're going to be dealing a lot with matrices and different forms of matrices, different dimensions. Typically, they're n by m matrices, right? Rows by columns. So when you find the inverse of a matrix, there's a lot of different ways to do it. It can't always necessarily be done. There's a few rules that um, you have to follow. One of them is that your matrix has to be a square matrix, and there's a few more to it. But the most common one is that of a 2 by 2 matrix. And so, what we're going to be doing today is just finding the inverse of just a 2 by 2 matrix. It should be pretty simple, pretty straightforward. So this is how it's going to go. So let's just say that we have an A matrix and it's a 2 by 2, two rows and two columns. And so we have four elements inside this A matrix. So we have A, B, C, and D, right? And just to remember, our rows are the ones that are going uh, like this is row one and this is row two. And then let's just say that we want to find our columns. Our columns are the ones that is one column and that is our second column. So just kind of like a quick refresher. So what is the inverse of this 2 by 2 matrix? So I'm going to dish out the formula and then we're going to go over it. So the inverse, typically we'll write it like this: A inverse is equal to 1 over what's called the determinant of A multiplied by another 2 by 2 multiplied by a 2 by 2 matrix. And we're going to change up the elements in this 2 by 2 matrix here. So where we have the A, the 1 1 element in the first matrix, we're going to write D there. We're going to swap the two elements. We're going to swap the D and we're going to swap the A. Okay, they literally just swapped, right? They switch places. And then for our C and B, we're going to multiply those by -1. So now it's negative B, and then it's negative C. Okay. So there's a lot of reasons kind of as to why this is the case, but it's a lot simpler if we just learn how to do it. And then maybe another time we can go over exactly the derivation on how to do this. So switching up the elements, finding the negative of them, it's not necessarily that hard. What is more concerning to a lot of people is what is called this guy right here, the determinant of A, the determinant of a matrix. A lot of people don't understand necessarily what that is. So a determinant of a matrix is just a very special number, and it gives different properties in the matrix. Not too bad, not too hard to find, especially on a matrix like this. So let me erase some of this stuff here. And in this case, we want to find, let's just say, the determinant of A. In any 2 by 2 matrix, what we do is we multiply the first element times this guy, so A times D, A times D, then we're going to subtract the product of these two, which is just C times B. And that is the determinant for a 2 by 2 matrix. Once again, the inverse of other matrices are going to look different, as well as the determinants of those matrices are going to look different. You're going to have similar operations for the determinants, but it's going to look a little bit different. Right now, we're going to take this on faith and we're just going to plug it back in. So what does this necessarily mean? Well, we have our A inverse matrix is 1 over the determinant, but we also said that the determinant is A times D minus C times B multiplied by this 2 by 2 matrix, which is just simply D times negative B times negative C times A. Excellent. Cool. So this is the formula for finding the inverse of a 2 by 2 matrix. So let's actually go do an example of it. Quick example, okay? So let's just say that we have an A matrix here. I have an A matrix. Let's actually make it different. Let's do B. I have a B matrix. And my B matrix is, let's just do 1, 4, 3, and 2. Okay. Now we want to find what is B inverse equal to, right? And we know from the formula that B inverse is equal to 1 over the determinant of B multiplied by, it's going to be the different elements switched. So in this case, we are going to have, it will be 2, 1. Remember, we're going to do the negatives up here, -4, and then -3. Okay, cool, but we still need to find the determinant of B. So the determinant of B is equal to, remember it's 1 times 2, which is just 2, subtract 3 times 4, which is just 12, happens to be equal to -10, right? So we can plug this guy back up here. What does this give us? This gives us that B inverse is equal to -1 over 10 times 2, -4, -3, and 1, right? And what we could do is we can multiply this matrix by whatever coefficient is in front of it. So let's go and do that. So what we are going to get is another matrix, and that's going to be a -1/10 times 2. That's going to be a -1/5. -1/10 times -4 is going to give us 2/5 reduced, right? -1/10 times -3 is just simply going to give us 3/10, and then -1/10 times 1 is just simply going to give us -1/10. Okay. So to re-illustrate, I'm going to actually end up deleting this guy. Okay. And I'm going to make this clear here. This is our B inverse matrix. Okay. So that's an example on how to find the inverse of a matrix. And once again, this is the general formula for finding the inverse of a 2 by 2 matrix, specifically 2 by 2 matrix. Okay.